So here to talk through this Nurikabe full puzzle by JinHoo called Number Snakes. It's a pretty curious puzzle, and it's curious for a couple of reasons. One of them is it's probably the first puzzle I can remember that shouldn't have a time standard on the site, and I think that's because the path we intend the solver to take, the logical, fun, interesting, curious path, is not the fastest one in this grid. It's actually rarely the case in a very small puzzle that deduction, particularly for the harder puzzles, that this is a Wednesday 6x6 puzzle. The harder path is the slower path. And that sounds tautological, but I mean, I mean it in some way. Like what we intend solvers to do, like really crack open the layers of this enigma, will be defeating the puzzle in some stage. So I might as well solve this video as if I'm a speed solver and say, well, got some big numbers here. Either the 6 is all an island or it's not. So let's say it's all an island. So these all come off, these come on, these come off. That's an issue. That's an issue. Okay, 6 is not an island. 6 is all shaded. These get shaded. This gets shaded off. This is shaded in. 2x2 rule. These are shaded in. On. There we are. You got lucky or you got unlucky, but that's 30 seconds, and that's at least half of the Grandmaster time as we posted it. All of our testers, including myself, took a slower path here, not just the racing path. And in taking that slower path, we saw some of the other curious things about this grid. This grid is amazingly anti-symmetric in that it somehow has one answer, but with this arrangement of snakes, it has 6 cells for the 1s and 6s, 7 cells for the 2s and 5s, and the same set of cells, again, rotationally symmetric for the 3s and 4s. So a really beautiful grid. And it really, on its slow but logical path, the hard and interesting path, it's using the Nurikabe full rules to their maximum extent. And that's what the snake shapes in this grid do. They kind of give a collective action to the grid. These 6 cells must be all an island or must all be shaded. Like everyone will get that. These 3 cells in the 5 also must be the same. Like it could be the case this is an island and this is shaded, but if any island in the grid is a 5 size, these 3 are part of it. If any island in the grid is a 4 size, these 3 are part of it. And if any island in the grid is a 3 size, this cell is a part of it. And that's because here are 5 cells. That's one extreme. This is the other extreme. There are a total of 3 snakes that you can make, and they all use this cell. And so these cells are critical at the start. And the first ones I actually marked in with circles in my paper copy of the grid to say these are different. And think about those collectively, and think about stuff near those cells collectively. And that's where there's maybe one key cell, we'll get to it 2 or 3 in, but one key cell that cascades a lot of the deductions. But we can start by first just saying, what is true about these snakes as they nest together? Well, here's a 2x2 group in the lower right of the grid, and they can't all be shaded. If the 6s is an island, this gets shaded for sure, but if these are all ocean, this must be part of that island. Otherwise, we have a 2x2 in the grid. So not only are these cells part of a force 5 island, this cell is part of a force 5 island, and that means we can never have an island with that 5. The next sort of things we'll all think about these groups colliding, and the way I've set this up is hopefully useful in these colors. I can actually, let me make it even more clear. Let's make this 3 the same color as this 4 group. And remember, if I cancel one of these big numbers, actually cancel all of the numbers when I'm shading. So let's say 5 is an island, then all that right now is in red, including all of the 4s that aren't in red, would be shaded as ocean. That should draw your attention to this cell. And that's because that would now make both the 3 groups and the 4 groups anathema to the grid. Like you couldn't have 3s or 4 islands. And this joining, it's kind of like crossing the streams. It would make all of this stuff get marked off. And so where there's a little bit of an odd even parity that you could see in the grid at the start, this cell is a key one because you can't join the 4s and 3s together or they'd all get canceled. And so if there is a 5 island, it's a vertical island only. It does not take this cell. And so we don't know any island cells for sure yet, but we know those 2 ocean cells, and the 5 is fully vertical if it exists. And that now will get us slowly to the true ocean and islands that we need. First is we now have a 2x2 tension here. So there must be a 3 island. This is the first sure island we know, and it shades this one off. We now really want to think hard about that 3 island and say, where can it go in the grid? And the first maybe potential cell to think about is, can it go all the way up to here? And you should see that it can't. If it does, it's going to touch to this cell, and it's also touching to this red group. And so all 4 of these cells at the top are marked off. So one way to work through this grid is to look here. But another way to work through this grid is to actually think about some conclusions that follow from knowing that this island must be here if it's there. If this is a fully vertical island, this cell is always part of the ocean. And if this island isn't there, if instead 6 is the island here, this is also always part of the ocean. So this cell can be marked off. So you should slowly chip away, but whether it's this cell or this cell, you should slowly be able to chip away and say this 3 has to extend a little bit in this direction. That's again going to mark off some stuff. Actually, maybe chipping away in this direction is enough. Let's say you never looked at this cell. You now actually know that you've got a 2x2 tension right here. And so 5 is actually for sure an island at this time in the puzzle. That marks this in down here, and we do cascade to the answer. And so, you know, it's a slow path to take, but it's that collective action of cells, these 6s, these middle 5s, the middle 4s, the joining of the 3s, 4s, and 5s. This is what was intended to be the way to think through the proof of having one solution here. And the solution hides its own little, one of the testers said this was an Easter egg. They saw a Fibonacci sequence here, 1, 1, 2, 3, 5. I don't think that could have been intended because it's hard enough to make this puzzle work on its own. But a lot of stuff to discover if you take the time to focus on this grid. Even small grids can have fun surprises. So worry less about the timing this week. Just think about the kind of logical elegance of getting to the solution. And hopefully you got something from listening to this video. Thanks for the time and attention. We'll see you again soon.